Here are some examples from day 22. This looks like an 8-part problem, and the first thing they want us to do here is select the graph of the parent function of f of x is equal to x to the third power. Now this comes straight from the notes. What we would look for is the graph that has points where the y is the cube of the x. So it looks like the ones that are graphed here have to fall inside of a window of for x up to possibly positive 10, y up to positive 10, x to the left negative 10, down negative 10. It had to fall in that window. So the parent points that I have that fall into that window were negative 2, comma negative 8, because negative 2 to the third power is negative 8, negative 1, 0, 0, 1, 1, and 2, 8. So I'd be looking for a graph that has those 5 points. I could tell the only one that fits that here would be C. So now they want says state the function's domain and range. That's also straight from the notes. The domain is all real numbers, and the range is also all real numbers. Identify the function's end behavior. Okay, so end behavior means what the arrows are doing. So this is an arrow notation here. So this says as x goes to positive infinity. That's just a fancy way of saying the right. So what is the right arrow doing? The right arrow is going up, so it means it's also going to positive infinity. As x goes to negative infinity, okay, that's a way of saying left. What's the left arrow doing? The left arrow is going down to negative infinity as well. Identify the graph's x and y intercepts. This happens to actually, they are one and the same. The cubic function will cross the x-axis at the origin, and the origin is also part of the y-axis. So 0, 0. Are they not letting me put it in as an ordered pair? Maybe they want it just as a value. So 0 and 0. Okay, good, they accepted that. Identify the intervals where the function has a positive value and where it has negative values. Okay, well, we know from the graph on the notes that a cubic function the parent function looks something like this, where it's above the x-axis once you cross the origin here on the right, and it's below the x-axis to the left of the origin. So the way I would describe that, the function has positive values on the interval x is greater than 0, because that's positive numbers. As you go to the right, the y is positive as well, and it has negative values on the interval x is less than 0. The reason why I don't have or equal to is because at 0, the function is neither positive nor negative because it's passing through the origin at 0, 0. Do they want it in interval notation? The function has positive values. Let's see if maybe they wanted it in interval notation, which would be 0, 0, comma, positive infinity, and then negative values would be negative infinity, comma, 0. Did they accept that? And that they accepted. It's the same thing as I was putting before. They just, they should have written there that they wanted it in interval notation. Identify the intervals where the function is increasing and where it is decreasing. So let's see, the function x to the third is decreasing on the interval negative infinity to 0 and is increasing on 0 to positive infinity. That should be correct. This actually no, I'm sorry, that's not correct. Because increasing or decreasing, no, the function is always increasing. Never mind. They weren't asking. I read it as if they were asking for what's the value of the value of the function. Increasing just means is as you go to the right, this is always going up, and that's also straight from the notes. The function is always increasing. Tell whether the function is even, odd, or neither, and explain. Okay, we said on the notes that this is an odd function. Now, on the notes, I gave you the explanation graphically, and graphically, an odd function has origin symmetry, but algebraically, if I say f of x is equal to x to the third, what would make this odd is that if I input a negative x instead of an x, negative x to the third gives me negative x to the third. Negative x times negative x times negative x is negative x to the third. So what happens is the sign changed. Instead of an x to the third, I have a negative x to the third. And that sign change is what causes this to be odd. So, f at negative x is negative x to the third, which equals negative x to the third, which equals negative f of x. Describe the graph's symmetry. Okay, and this one we talked about on the notes. This has origin symmetry. And that's correct as well. Describe how the graph of g of x is related to f of x is equal to x to the third. So how does this graph relate to the parent function? Because I don't see a parentheses here, that -3 counts as an a. And we know that a is in charge of vertical stretch and compress, and x-axis flips. So this is being stretched vertically by a factor of 3, and the a does x-axis reflections. Describe how this graph is related to f of x equal to x to the third. Well, now since there is a parentheses, that 7 is still multiplying, but it's multiplying inside the parentheses, so that means it's going to be horizontal. When the number is greater than 1, it's a horizontal compression, and since meaning that it's a b, and here my b value is 7, and if you remember from the formula, I'm supposed to do x over b plus h. So if this were to be applied, since I would be dividing by 7 is the same thing as multiplying times 1 over 7, which is why they want you to express it using multiplication. This book has done this like this before, so that's why they want this as 1 over 7. Describe how this is how x plus 1 to the third is related to the parent function. Because that plus 1 is inside of the parentheses, that means that it's an h. But remember, with h, if you see a plus 1, h is really -1. So this is going to be a horizontal translation of 1 unit to the left. So I'm going left 1 unit. Describe how this graph is related. So here I see subtraction, but there is no parentheses. So that means that -11 is a k. K is vertical translation, so this is going to go down 11 units. Identify the transformations that produce this graph. And then select which graph would apply. So here, since there is no parentheses, this 1 over 5 would be an A. So this is a vertical compression by a factor of 1 over 5. Now, if I wanted to graph this, I would have to apply this using my formula, but since A is the only transformation number, we know that A gets multiplied to the y's. So I would want to, well, I could pick whichever points I want. Ideally, I would want to pick parent points that have a y that's divisible by 5, but it looks like here from the directions, they want me to only pick these parent points that are here. Well, 0, 0, which is this parent point over here, that's going to turn into hk. So since there is no parentheses, h would be 0. And since there's no adding or subtracting, k is also 0. So we're going to keep 0, 0. Now, as far as -1, comma -1, all that would happen, the -1 on the x would stay the same, and the -1 that's on the y would be multiplied times 1 over 5. So that would give me -1, comma -1 over 5. That would be 1 point that's on this graph. For 1, 1, which is they also want me to use 1, 1, the x would stay the same, and the y would be multiplied times 1 over 5, so that would be 1 and 1/5. So it looks like in blue they have the parent function. In red they have the transformed function. So the one that it has to be, it looks like it would be D. D looks like it's the one that has the points that I found. Identify the transformations that produce the graph. So here on this graph we have an A, that's 1, B is also 1, H is -5, and K is +3. So this is going to be a the horizontal translation is going to be 5 units to the left, and then we're going to go 3 units up. They want me to transform the same 3 points. Well, I know that 0, 0 is going to turn into H and K, which is going to be -5, 3. So that's 1 point I'm going to have on my graph. The -1 point that they want me to transform, I'm supposed to divide by B for the x, but B is 1, so I can ignore that. So all I got to do to the x is just subtract 5. And for the y, which is -1, I want to add 3. So that's going to give me -6, 2. I'll do the same thing for 1, 1. If I get 1, 1, the x, I take away 5. The y, I add 3. So this is going to give me -4, 4. In blue, they have graphed the parent function. In red, they have the transform one, and the one that has the 3 points that I just found here is C. Okay, a general equation for a cubic function is given along with the function's graph. Identify the values of the parameters from the reference points, and then drag and drop. So they're giving us some points here, and they want us to be able now to write the function. And it looks like specifically on this one, what they're looking for position-wise looks to be, this is in the B position, an H, and a K. So we'll keep that in mind. Just like we've seen with previous functions, the H and K can be gathered from the graph. On a cubic function, the HK is where the graph is at its flattest. So here that happens at 2, -1. So I know that my H is going to be 2 and my K is going to be -1. Since A and B are capable of doing a lot of the same things, I'm going to want to keep one of them at 1. So since here it looks like they want me to find B, I'm going to keep A at 1. So B is really what I need to look for. I need to figure out what B is. But in order to do that, I need to temporarily use another point. I can use whichever point I want. They're giving me 2 other points here. Since I love substituting the 0, I'm going to use 6, 0. And now I'll plug that into the formula that I gave, which said y equals. So instead of y, I'll use 0 equals A, but A is 1, parentheses, B, which is what I'm looking for, parentheses, x minus h, which is going to be 6 minus 2. Here, this is a cubic function, and then plus k, which is -1. And now I'll solve for b. I get 0 equals 4b. to the third power minus 1. So I'll go plus 1, cancels out. 1 equals 4b to the third power. I'll go ahead and do the cube root now. I can do a cube root to cancel out a cube. Unlike with square roots, there is no cube root property. There is no plus minus. So the cube root of 1 is just 1. And that gives me 4b. So I divide by 4. And b is equal to 1 over 4. So this looks like it should have undergone a horizontal stretch. So let's move this 1 over 4 over here. H was going to be 2. And K is negative 1. Plus negative 1 is the same as minus 1. We'll do one more of these. Okay, same type of problem, but now, based on what they're looking for, we're looking for A, H, and K. Since this first space is outside of the parentheses, they want an A. So A is going to be what I'm looking for. We'll leave B at 1. H and K are where this graph gets at its flattest, which here is at 2, 4. So H and K is going to be 2 and 4. And I need an X and a Y temporarily. So I'll just pick 3, 1. I could have also used 1, 7. So then my equation will say not y equals, but 1 equals the A that I'm looking for. Parentheses, since B is 1, I don't need the B. The X I'm using is 3, minus H, which is 2, cubed, and then plus 1. So 1 equals 3 minus 2 is 1, 1 cubed is 1, so it's A plus 1. Something had to have gone wrong here. What did I do wrong? 3, 1. 2. Oh, I'm sorry. This should have been a 4 here, not a 1. I wrote K goes there. I wrote a 1 instead of a 4. So A should be A plus 4. So minus 4 minus 4. A is negative 3. H is 2. And K is 4.